Hello, myself Shubhashish Shah, Assistant Professor of Mathematics of Greater Kolkata College of Engineering and Management, GIS Group. In this video, I will discuss about solution of ordinary differential equation using Laplace transformation. In my previous videos, I have already discussed about Laplace transformation and inverse Laplace transformation. So in this video, I will discuss about solution of how to solve ordinary differential equation using Laplace transformation. To solve an ODE using Laplace transformation, inverse Laplace transformation is also required. So the name of the chapter is solution of ODE using Laplace transformation. Okay. So let's start. The general procedure to solve an ODE, we have to take first Laplace transformation of the ordinary differential equation at the both sides, and then to take inverse Laplace transformation on the both sides. Then we will get the Laplace transformation of the solution of the ODE. So let us take an example. Number 1, d square by dx square plus d square by dt square plus 2 dy dt plus 5y equal to e to the power minus t sin t, y0 equal to 0 and y dashed 0 equal to 1. Okay. So first we have to take Laplace transformation both sides, and we let that L of yt is fs. Okay, we will denote Laplace transformation of yt by fs, function of s. Now taking Laplace transformation both sides, taking Laplace transformation both sides. Okay, so what will be the next line? L of d square y dt square plus 2L of dy dt plus 5L of y means actually y is a function of t, equal to L of e to the power minus t sin t. Okay. Now L of d square by dt square means we know that Laplace transformation of second order derivative. What is the Laplace transformation of second order derivative? It's a square yt, a square L of yt, that is a square fs minus s y0 minus y dashed 0 plus 2 into s fs minus 2 y0 plus 5 f of s equal to L of sin t is 1 by s square plus 1, and since e to the power minus t is multiplying sin t, so we have to use first shifting property, and this will be s plus 1 whole square plus 1. Okay. Now we have to put the initial value given in the question. So y0 is equal to 0, it is given, and y dashed 0 is equal to 1. So we are taking common fs, it will be a square plus 2s plus 5, and since y0 is 0, it will be 0 and it will be 0, and y dash 0 equal to 1, so minus 1 equal to 1 by s plus 1 whole square plus 1. So fs equal to 1 plus 1 by a square plus 2s plus 2. This is splitting by splitting the formula, a square plus 2s plus 2 into 1 by a square plus 2s plus 5. Okay. Now I'm doing LCM, and this will be a square plus 2s plus 2 into a square plus 2s plus 5, and this will be a square plus 2s plus 2 plus 1, that will be 3. Okay. Okay. Now we can write this as s plus 1 whole square plus 2 by, this can be written as s plus 1 whole square plus 1 and s plus 1 whole square plus 2 square, that is 4. Okay. So using, okay, so if we want to actually solve the ODE, so we have to find the function yt. So fs is actually L of yt. So if we want to find yt, then we have to take inverse Laplace transform of the function. So s plus 1 whole square plus 2 by s plus 1 whole square plus 1 into s plus 1 whole square plus 2. Okay. So yt equal to, since this is there is all the function containing s plus 1, so by first shifting property we can write that e to the power minus t L inverse of a square plus 2 by a square plus 1 into a square plus 2. Okay. No, sorry, it will be 2 square, that is a square plus 4. Okay. Now we have to split it in partial fraction. So I'm removing this. So let a square plus 2 by a square plus 1 into a square plus 4 equal to as plus b by a square plus 1 plus bs plus cs plus d by a square plus 4. Okay. Now comparing both sides. Okay, first we perform LCM. A square plus 1 into a square plus 4. A square plus 4. Then it will be as plus b into a square plus 4 plus cs plus d into a square plus 1. So the denominator will be cancelled out. So if we compare the coefficient of a square both sides, then we can see, okay, we can also compare the coefficient of s cube. Then it will give us a plus c equal to 0. as cube and cs cube, a plus c equal to 0. This is one equation. And now from the comparison of coefficient of a square, that is b and from here it will be b plus d equal to 1. Now from the coefficient of s, comparison of coefficient of s, S is 4as, that is 4a plus C equal to 0, and from the constant 4b plus d, 4b plus d equal to 2. Okay, 4b plus d equal to 2. So comparing these two, solving these equations, okay, so we get b plus d equal to 1. So b equal to 1 minus d, we are putting b equal to 1 minus d plus d equal to 2, that is minus 4d plus d will be minus 3d, and 4 plus 4 it will be minus 2. So d will be 2 by 3. D will be 2 by 3, and b is 1 minus 2 by 3, that is 1 by 3. Okay. Now from these two equations we get a and c will be 0. A and c will be 0. So we can write here e to the power minus t after performing the method of partial fraction. It will be, since a and c 0, so b equal to 1 by 3, therefore 1 by 3 into a square plus 1 plus L inverse of d is 2 by 3. So 2 by 3 into 1 by a square plus 4. Okay, a square plus 4. Now it will give us 1 by 3 into sine t plus e to the power minus t into 2 by 3 into half into sine 2t, So here 2 will be cancelled out. So e to the power minus t by 3, e to the power minus t by 3 into sine t plus sine 2t. Hence the solution. So yt equal to e to the power minus t by 3 sine t plus sine 2t. This is the required solution of our given ordinary differential equation. Okay. Now I will go to next problem. The next problem is d square plus 6d plus 9 operating on y equal to 1, and given y0 equal to y dash 0 equal to 1. Okay. So this is also we have to do this by Laplace transform, and here it is given that d is equivalent to d dx. So y is a function of x, so let L of yx equal to fs. Okay, so we have to take Laplace transform, taking Laplace transform both sides, so it will give us L of d square y dx square plus 6L dy dx plus 9L of yx and L of 1. Okay. Now L of d square y dx square will give us a square L of yx, that is fs, minus s y0 minus y dashed 0 plus 6 into L of dy dx. This will give us s fs minus 6y0 plus 9 into L of yx is fs, and L of 1 is 1 by s. Okay, now here the initial conditions are given that y0 and y dash 0 is both equal to 1. So y0 is 1, y dash 0 is 1. So we are putting the values. So first we are taking common fs from 1, 2, 3, these three terms, that is a square plus 6s plus 9, and if we put the values of y0 and y dash 0, it will be minus s minus 1 minus 6 equal to 1 by s. So fs into a square plus 6s plus 9 is equal to, we are transferring this in the right hand side, so s plus 7 plus 1 by s, and fs will be equal to, okay, we are performing LCM, a square plus 7s plus 1 into 1 by a square plus 6s plus 9. Okay, and this is equal to a square plus 7s plus 1 by s into, this is s plus 3 whole square, s plus 3 whole square. Now fs means we know L of yx. L of yx is a square plus 7s plus 1 by s into s plus 3 whole square. Okay, now to get yx, we want yx, the solution of the ODE. To get yx, we are taking inverse Laplace transform both sides. So yx will be L inverse of a square plus 7s plus 1 by s into s plus 3 whole square. Okay, now to find the inverse Laplace transform of the mentioned function, we first apply method of partial fraction. So I have already discussed about method of partial fraction in my previous video. So let a square plus 7s plus 1 by s into s plus 3 whole square. This can be written as a by s plus b by s plus 3 plus c by s plus 3 whole square. Okay, so we have to find the values of a, b and c. So a equal to limit s tends to 0 a square plus 7s plus 1 by s plus 3 whole square. Okay, now since s is tending to 0, it will be 1 by 3 square, that is 9. So the value of a is 1 by 9. Now applying limit, we can find the value of c also. So c will be equal to limit s tends to minus 3 a square plus 7s plus 1 by s. So minus 3 square, that is 9 minus 21 plus 1 by minus 3. So 10 minus 21 is minus 11, that is 11 by 3. So the value of c is 11 by 3. Now to find b, we have to compare the coefficients both sides. So we are putting the value of a and c first. So a square plus 7s plus 1 by s into s plus 3 whole square equal to 1 by 9 into 1 by s plus b by s plus 3 plus 11 by 3 into s plus 3 whole square. Okay. Now first we'll perform the LCM, then we'll compare coefficient. So s into s plus 3 whole square is the LCM, and 1 by 9 into s plus 3 whole square plus b into s plus 3 plus 11 by 3 into s. Okay, now see, this is s square plus 7s plus 1 by s into s plus 3 whole square. So this is being cancelled out since they are same. Okay, so comparing both sides of the numerator, we are first comparing the coefficient of a square. So in the right hand side, the coefficient of a square is 1 by 9 plus b. 1 by 9 plus b is equal to, on the left hand side, the coefficient of a square is 1. So b equal to 1 minus 1 by 9, that is 8 by 9. So b equal to 8 by 9. Now we put the value of b here and we got a and c before. So a square plus 7s plus 1 by s into s plus 3 whole square equal to 1 by 3s plus 8 by 9 into s plus 3, and c was 11 by 3. 11 by 3 into s plus 3 whole square. So yx, okay, I am doing here. So yx was L inverse of this function, that is 1 by 3s plus 8 by 9 into L inverse of 1 by s plus 3 plus 11 by 3 into L inverse of 1 by s plus 3 whole square of that. So 1 by s, L inverse of 1 by s is 1, so it will be 1 by 3 plus 8 by 9 into L inverse of 1 by s plus 3 will be e to the power minus 3t plus L inverse of 1 by s plus 3 whole square, that is e to the power minus 3t into t. So yx equal to this. So this is the required solution of the given ODE. Okay. Now I'll go to next example. Okay, so the next example is d square by d square y dx square, no, d square by dt square minus 3 dy dt minus 3 dy dt plus 2y equal to 4t plus e to the power 3t, and it is given that y0 equal to 1 and y dash 0 equal to minus 1. Okay, so first let us take that L of yt is fs. Okay. Now we have to take Laplace transform both sides. Taking Laplace transform both sides. So L of d square by dt square minus 3L of dy dt plus 2L of yt equal to 4L of 4t plus L of e to the power 3t. Okay. Now L of d square by dt square, that is s square, L of yt is fs, so fs minus s y0 minus y dash 0 minus 3 into L of dy dt, that is s of s into fs minus 3y0 plus 2 L of yt is fs, 2fs equal to 4 into L of t. L of t will be 1 by a square plus L of e to the power 3t. So L of e to the power 3t will be 1 by s minus 3. Okay. Now we have to put the values of y0 and y dash 0, which are given in the initially in the given ODE. So, and we are taking common fs from the terms which is containing fs, which are containing fs. So it will be a square minus 3s plus 2. fs is common, and y0 is 1, y dash 0 is minus 1. So it will be minus s, y dash 0 is minus 1, so it will be plus 1, and it will be minus 3, okay, equal to 4 by s square plus 1 by s minus 3. So fs into s square, okay, it can be written as s square minus 3s plus 2. Okay, now minus s minus 2, and it is 4 by s square plus 1 by s minus 3. Now if we factorize this, it will be s minus 2 into s minus 1, and it will be 4 by s square plus 1 by s minus 3 plus s plus 2. Now fs equal to, we are transforming this from left hand side to right hand side. So 4 by s square plus 1 by s minus 3 plus s plus 2 into 1 by s minus 2 into s minus 1. Okay. Now fs equal to, we are first we are performing LCM, that is s square into s minus 3. It will be 4s minus 12 plus s square plus s square plus s plus 2 into s minus 3 into s square. Okay, and this will be s minus 2, s minus 1. Okay, now it will be equal to s square into s minus 3 into s minus 2 into s minus 1, and the numerator will be 4s minus 12 plus s square, and it will be s square into s square plus s to the power 4, and it will be minus 3s plus 2 is minus s, that is minus s cube, and minus 6s square, minus 6s square. Okay, so this is equal to s square into s minus 1 into s minus 2 into s minus 3 and s to the power 4 minus s cube minus 6s square plus s square, that is minus 5s square plus 4s minus 12. Okay, now this is fs, so fs means L of yt, L of yt, and we need to find yt. So now we have to take inverse Laplace transform both sides so that we get yt. So yt equal to L inverse of s to the power 4 minus s cube minus 5s square plus 4s minus 12 by s square into s minus 1 into s minus 2 into s minus 3. Okay. So first we have to apply method of partial fraction to find the inverse Laplace. So let s to the power 4 minus s cube minus 5s square plus 4s minus 12 by s square into s minus 1 into s minus 2 into s minus 3 equal to a by s plus b by s square plus c by s minus 1 plus d by s minus 2 plus e by s minus 3, and performing the LCM we get this. Okay. Now since we can see that the denominator in the both sides is same, it can be cancelled out, so the numerator will be equal. So now comparing the coefficients, we have to find the values of a, b, c, d and e. Okay. Now first we compare the coefficient of s to the power 4 both sides. So coefficient of s to the power 4 in the right hand side is a 1, 2, 3, 4, and here there is 1 s to the power 4 a plus c, and here there is 1 to the power 1 s to the power 4 plus d plus e. A plus c plus d plus e equal to 1. In the left hand side the coefficient of s to the power 4 is 1. Okay. Now comparing the coefficient of comparing the constant, we get okay, here there will be no constant. Here there is 3 into 2 6 minus 6b minus 6b, and there will be no constant. So minus 6b equal to minus 12. So b equal to, we can write 2, b equal to 2, and in this way if we compare the coefficients both sides, then we will get this function in the form of partial fraction like this. You will do it. Fs equal to 3 by s plus 2 by s square minus 7 by 2 into s minus 1. Okay, you can also find the value of a, c, d and e, applying limit b, c, d and e. Now b equal to limit s tends to 0, s tends to 0, s to the power 4 minus s cube minus 5s square plus 4s minus 12 by s square into s minus 1 into s minus 2 into s minus 3. So if s is tending to 0, then it will be minus 12 by minus 1 into okay, so there will be no s square, so minus 3 into minus 2 into minus 1, that is minus 6. So b will be equal to 2. Okay, now c equal to limit s tends to 1, s tends to 1, s to the power 4 minus s cube minus 5s square plus 4s minus 12 by s square into s minus 2 into s minus 3. Okay, so this will be s tends to 1 means 1 minus 1 0. Okay, 1 minus 1 minus 5 plus 4 minus 12 by minus 1 into minus 3 minus 2, that will be 2. Okay, so this will be equal to 1 is cancelled out, minus 1 minus 2, so minus 13 by 2, minus 13 by 2, c is equal to minus 13 by 2. Now d equal to limit s tends to 2, limit s tends to 2, s to the power 4 minus s cube minus 5s square plus 4s minus 12 by s square into s minus 1 into s minus 3. So it will be 2 to the power 4, that is 16 minus 8 minus 20 plus 8 minus 12, and that will be, no, this will be 8. Okay, so that will be 4 into 1 into 2 minus 3 minus 1. Okay, so this will be equal to 8 is cancelled out, so 16 minus 20 minus 4 minus 4 minus 16 by minus 4, that is 4. Okay, so the d equal to 4. Now e equal to limit s tends to 3, s tends to 3, s to the power 4 minus s cube minus 5s square plus 4s minus 12 by s square minus s minus 1 into s minus 2. So this will be equal to 81 minus 27 minus 45 plus 12 minus 12 by 9 into 2 into 1. So this will be equal to 12 is being cancelled out, so 5 plus 7 12, 4 plus 2 6 7, so 62 72. So 81 minus 72 will be 9 by 18, that is half. Okay, okay, so 7. So we have found out B, C, D and E, the values of B, C, D and E, and A is remaining. Now to find A, okay, here we write B equal to 2, C equal to minus 13 by 2, D equal to 4, E equal to half. Okay, now to find the value of A, we will compare the coefficient both sides. So if we compare the coefficients of s to the power 4, it will be A plus C plus D plus E equal to 1. In the left hand side, the coefficient of s to the power 4 is 1. So we are putting the value of C, D and E. C is minus 13 by 2, D is 4, E is half, equal to 1. So A will be equal to 1 minus 4 minus half plus 13 by 2, and that will be equal to 2 minus 8 minus 1 plus 13, that is 15 minus 9, 6 by 2, and that is equal to 3. So yt, okay, so yx will be L inverse of A is 3, so 3 by s plus L inverse of 2 by s square minus 13 by 2 L inverse of 1 by s minus 1 plus 4 into L inverse of 1 by s minus 2 plus half into L inverse of 1 by s minus 3. So L inverse of 3 by s, L inverse of 3 by s is 3 into L inverse of 1 by s is 1. So 3 plus 2 into t, okay, it will be t. So 2t plus minus 13 by 2 e to the power t, L inverse of 1 by s minus 1 will be e to the power t plus 4 e to the power 2t plus half into e to the power 3t. So yt equal to 3 plus 2t minus 13 by 2 e to the power t plus 4 e to the power 2t plus half e to the power 3t. So this is our required solution of the given ODE. Now in this way we can solve an given ODE using Laplace transformation and inverse Laplace transformation. So in this video, that's all. You watch this video. I have already published some videos previously for Laplace transformation and inverse Laplace transformation. Without watching those videos, you can't understand or you can't solve this ODE watching this video. So you need to watch those videos first, then you can understand this video. So if you have any query or question regarding this video, you can ask me, you can contact with me. My contact details is given at the first slide of this video, and you must practice this type of sums so that it can be easier to you. So for this video I finish here. Thank you.